Hey everybody and welcome back. So this is the big one. This is the day we're going to deploy Kubernetes. Now in my previous video I mentioned that I'd be using KubeSpray, and I've got a confession. We're not going to be using KubeSpray. That's because I've come up with my own script that I want you guys to use and improve. That's right, I want this to be a community driven script, and I want all of you great folk out there to be able to improve upon what I've created. What I set out to do in all of these videos is create the simplest experience I can for you guys to try out enterprise grade infrastructure and services. And whilst looking at things like KubeSpray and Ansible, both of which I think are great tools, and we'll come on to those in later videos. However, I wanted something that was really simple, easy to maintain, and something that you guys would be able to get a grasp of and understand. But equally, it just works, and it does everything that those tools would do in a minimalist fashion. And as you can see, it's just a single script that you need to run once you've configured some variables. So in this video, we're going to walk through the script. I'm going to tell you all of the variables that you need to change, and then I'm going to tell you a bit about what the script is actually doing. Then we're going to get onto the actual deployment, and then we should hopefully at the end of this video have Kubernetes running in HA mode with a load balancer, and we should have an example Nginx container spun up. So let's get into the script, how it works, what it's using, and what you need to change, and then we'll get onto deployment. So as you can see, this literally is just a bash script, but it calls upon some important third-party applications. Namely, those are K3S up, affectionately known as Ketchup. Now, what that does is it takes K3S, so that's the version of Kubernetes we're running here, not K8S, that's the enterprise level full fat. This is a stripped down single binary that's a perfect choice for homelabbing. What that does is it takes the burden out of the sign up and the initial registration of different nodes. If you wanted to do this just with the native tooling, there's a number of steps which you'd have to do manually. Now, this is going to automate all of those for us, but it's still going to give us the level of control that we need to make sure that we understand and can configure everything to our liking. On top of that, it's going to download kubectl, that's the kube controller. We'll use that to make commands against our cluster. You can see those at the end of the script. There's also Docker thrown in there for good measure, and I'll get onto why that's required in a minute. But it's basically to spin up a container and generate a manifest file. And that's pretty much it. Like I say, I designed this specifically to be as minimalist as possible, and I hope that doesn't change in the future. Now, this script is going to evolve over time, I hope, with your guys' contributions, but the process and at least my vision for this is going to remain constant. I just want this to be a simple one-click solution to get you the bare minimum required to have K3S up and running. So let's jump into the bits that you need to configure first, and then we'll look through how it works. So if you look at the top of the deployment, you can see that we are specifying a version of kube-vip. Now, kube-vip is what is going to do the HA, the high availability for us, and it's what's going to do the load balancing for us. So with high availability in K3S, you typically work with a master and an agent notation, or a master and a worker. Now, the master is responsible for keeping all of the cluster knowledge alive, so to speak. So all of the configuration details, all the key value pairs, etc. Now, if one of those were to go down and you only had one, your cluster would fail. So high availability is important. And if you remember in the last video where we set up 5 virtual machines, there's a reason for that. We're going to have 3 master nodes and 2 worker nodes. So that means we could have a node failure of each, and everything should still be up and running. So that's exactly what this variable here is doing. It's setting the kube-vip version to 0.6.3, which is the latest version. After that, we're going to specify the IP addresses of all the virtual machines we created in the last video. Now, you just need to tweak these IP addresses to your virtual machines and everything should be fine. I've put them on their own separate VLAN and I've used consecutive IP addresses, and I've also made these static within the DHCP lease of my firewall, but there's a million and one ways you can do this. Just make sure that they're static and they're always going to get assigned to the same node. Next up is the user. Now, because I'm using that cloud image, all of my users are called Ubuntu. So I've specified the name Ubuntu here. Next up is the interface. Now, on that image we used, that is ETH0, Ethernet 0. That's the default Ethernet port. So that's what I've set here. Now, I just want to interject here, and I probably should have mentioned this earlier. I've done my absolute best to test this, but I'm only one person with limited resources. And from the last video, you know that I used 2304 of Ubuntu Cloud Image. Now, I've spun this up lots of times and it's worked every time. And it should work on 2204, and fingers crossed, because the way I'm deploying this, and I'm leaning heavily on the tools that are provided in the convenience scripts, I think this should work cross-platform. But I'd love you guys to test that with things like a Raspberry Pi and report back, and with a bit of help, I'm sure we can get there for that one single-click solution across all architectures. Next up, and this is the really crucial bit, this is the virtual IP. And this is how that high availability works. It creates a virtual IP address that's shared across all of those masters. So whenever a pod is calling out or a node is calling out on this IP address, it can be picked up by any of those masters. And as you can imagine, if one of them fails, the other two will pick it up, hence high availability. The next two sections are simply calling out what the masters are and what the workers are. So I've just created an array here, and you'll notice that master 1 is missing. That's because master 1 has to be the control node to begin this whole process. So it's set up as the cluster. Then we're going to join the other masters to that cluster. So we'll have 3 masters and they'll all be synced. And then below that, you'll see the workers. So I've specified those IP addresses, which relate back up to the top. And those are going to be our workers, and we'll join those at the end once we are correlate with our 3 masters. And the last bit you have to change is simply the load balancer IP range. So as I said, I'm using kube-vip and it's a load balancer. Jim, what does that mean? Well, you'll see in this demonstration that we're going to spin up Nginx. Now, you need to have a load balancer to be able to access that service. Traditionally, in a cloud environment, so something like Google or AWS, you wouldn't need to worry about this because their load balancer would take care of access to your pods. But we're not in the cloud, we're having to replicate that functionality internally. And with kube-vip, we can do that by specifying a load balancer IP range. So this IP range here from 60 to 80 is where my pods will be exposed. Now, every single pod I spin up, if I want to expose it, I can put it on an external load balancer. So, for example, I don't know, a Minecraft server. I could put it on an IP address within that range, and it would be load balanced across the Kubernetes cluster, and you would be able to access it on the IP. Very similar to how you access services in Docker in principle, but different in terms of the way it's architectured and executed. So obviously with this range in mind, you could have separate services on all of those IP addresses, 61, 62, 63, etc. You can make this as wide as you want and just tailor it to your needs. But just remember that you can put multiple services on an IP address, similar to how you probably have your Docker setup where you might have one Docker IP, but you've got loads of different services all running on different ports. More on that in later videos. And that's it. That's all you have to change to get this up and running. So with 2304 installed as your base OS, that's the one I've tested, but others should work. And these variables configured and correct, that's all you need. There are some steps before we actually execute it, but it's simply to download this script, change it so it's executable, and just copy across your certificates. The script's going to take care of everything else. So let's have a look what the script does. You'll notice I've made it pretty easy. Do not edit below. So the first thing here is it's going to set the time on and off. Now, this is a debug and it can largely be ignored. It's just because during testing, I was snapshotting my VMs and having to roll them back time and time again. And because my snapshot was a few days old, some of the installations would fail, like Docker, because it was saying things like the certificates didn't match because the time of my server was different to the current time. So all this does is turn the automatic time sync off and then turns it back on, and that forces a refresh of the time, i.e. the time is up to date. And it works. The next thing to do, and this is more just again a convenience thing for you guys, is dump your certificates for connecting to your VMs in your root home location. This will just copy them and change the permissions so we can use them to do SSH from this script into your virtual machines, which will be necessary for setting up the cluster. I showed in my last video where to get these certificates from, but they're basically just on your Proxmox host and you can copy them across no problem. This next section installs the necessary tools. Now, the bit I haven't mentioned here is this script is designed to be run outside of the cluster. So those 5 virtual machines you created in my last video we're not running that script on those. We're running this script on either another virtual machine or possibly your current machine that you're on, or basically anything remote that can execute this script. And what it's going to do is install some dependencies onto that machine so that it can run the rest of the script. Now the first one is that K3S, or that ketchup. And like I said before, that's a convenience tool for helping to automate some of the K3S deployment with some arguments, and we'll come on to those in a minute. So this is simply looking to see if it's already installed. If it's not installed, go ahead and install it. The next bit is to download and install kubectl, and this is just a tool for managing a Kubernetes cluster. Again, it's going to look if it's installed. If it's not, it's going to install it. The last piece of the puzzle is Docker. And like I said before, that's just to spin up a container, an ephemeral container, just to generate a manifest file that gets deployed to the cluster. It's basically all the keys and the configuration for the cluster. This is just using the Docker convenience script, so not necessarily what you'd want to use for a production environment, but all we want to do is just to spin up the container, generate the file, and that's it. The next line here just takes your SSH keys that you've copied from your Proxmox hosts, it copies it into the known key repository, so you're not going to get an annoying prompt to click yes. It just basically bypasses that. Now I've put brackets, don't use this in production, but I think it's fine given it's your home lab and you trust those certificates because you've just created them. So step one is where the magic starts to happen. And this is where we use Ketchup to bootstrap our first node. So as I said before, the first node isn't within that array because this is the one that's going to be the cluster initializer. So there's some special parameters that we need to pass to it to begin this process. So you can see that it does ketchup install. It's given the IP of master 1. So remember, this isn't the machine we're on now. This is the first one in my node. So for me, it was test K3S-01. So that's where it's connecting. It's going to use the user of Ubuntu, which is what we specified. It's going to set the SAN to be the VIP IP address. So this is the IP address that's virtual and shared between all of the master nodes for communication and high availability. Next up is we're going to set this to cluster mode, and that's what's required to start the K3S enrollment of your cluster. None of the other nodes will have the cluster. They will either be a server or an agent. I've set the K3S channel to be stable, so it's going to pull the latest version of K3S, which I think is 1.27. It's going to take some extra arguments for K3S. Now these are specific arguments specific to K3S. So it's going to say disable traffic. Now that might sound odd, Jim, you use traffic in all your videos. That's right, I do, but I don't want K3S to install it for me. I want to do that later. And that will be one of the first applications we install in the upcoming videos. Again, I want to disable the load balancer because this isn't in the cloud. We need to do it ourselves. And so we disable the native one within K3S, which listens for a cloud provider, and we're going to specify kube-vip later on in this script, and that's going to take care of this for us. We've set the flannel interface to be eth0, and flannel is responsible for doing all the networking within K3S, or at least can be. There are others like Calico that you could use, for example, but we're going to use flannel because that's the default. And lastly, we're going to set this node IP to its IP address, which you can see is master 1. It's going to use the merge command, which is going to merge the kube-config file for this server. So there's already one there, a default. It's going to append the additional values onto the end of that. Next up, it's going to run a sudo because we want it to have administrative privileges when it's installing this. We're going to set the local path of the config for this. So what does that mean? Well, that is actually the local path on this machine you're installing it from. Remember, this isn't within the cluster. But we need this config file to be able to run kubectl, so that kube control command line interface, on this machine, so we can actually then query and control our cluster remotely, which is awesome. It means we don't have to log in to any of those cluster machines. The next bit is just specifying those certificates that it's going to use for SSH into those virtual machines. And the context of this is just going to be K3SHA, and that's the name for the config file for this cluster. After that, it's just going to spit out that it was successful. Moving on, it's going to initialize that K3SHA, so that kube-config file, and it's going to apply a manifest file for role-based access control. So this helps to set up all the permissions and what K3S is able to do. I don't want to get too into the weeds in the RBAC files yet and manifest files. We'll come on to that later in the series. The next is just to run Docker container. So as I said before, we need to generate a config file, or more accurately, a daemon set. So what it does is it runs the container, It creates the interface to be eth0. It specifies the address to be the VIP. It says it's in a cluster. It gives it a taint of a master. Now, taints are labelings. We'll come onto that more in the future, but it helps to assign pods to certain nodes. For example, you could have a taint or a label for a worker node, and you want to make sure that all your pods only go onto that. Similarly, you might have one with a GPU. You could give it a GPU tag, and pods that need a GPU, you would give those a tag, and it would always go and look for a node that has a GPU on it. More on that later. Finally, we're going to set up the leader election to make this the lead node. Then we're going to write that out to the home directory as kube-vip.yaml. So it's going to create a YAML configuration file. After that, I'm going to copy that YAML file over to the first machine. And then it's going to copy that file over to that first master. And it's going to move it to where it expects it, which is in the varlib rancher K3S server manifest folder. Now that we've added our first master node, our cluster leader, we want to add in the new master nodes for high availability. And those new master nodes are just here. So it's going to iterate through that array of master nodes. In this sense, it's just the extra 2 IP addresses. And it's going to go through and set these up as replicas of the first. So you can see that here denoted by the server. And it's got some additional extra arguments, which are just the same as the primary, that elected leader. So once that is completed, that loop, you will have 3 highly available master nodes. After that, we want to set up the agents, and you can see that it's basically doing the same command, that join command, but there's a few subtle differences. Here we're telling it that it's not a server, so that's going to not create it as a master node, and we're later going to use these as worker nodes. Now you might be thinking, well, if we want high availability, why don't we put these master nodes on all of them, make them all master nodes? And I kind of get where you're coming from. But the issue you can get with that, certainly at scale, is that if your master nodes become bloated or resource compressed and it was using that specific master node at a time, you can run into issues. And also, you don't want to have too many master nodes because they're constantly trying to talk to each other. And the more traffic, the more overloaded the network becomes, etc. And it's actually a lot more complicated than that. And you can find out reasons why not to do that within the documentation. So go and have a read. But the key reason we don't want to do that is for memory and additional overhead. We don't need more than 3 in a home lab, and we can use those extra resources to host things like more containers on the worker nodes themselves. After we've done that, we want to go and deploy the load balancer, and you can see that here in step 7. So the good news here is it's reaching out to the web and just pulling that down. So we should always get the latest version of this, and that's good for compatibility reasons. What this is doing is then setting up that load balancer I mentioned earlier so that we can begin to expose services. Once it's downloaded that script, it's going to deploy it and it's going to specify the load balancer range that we created at the start within the user variables section. And you could actually just stop the script here because everything should be deployed and working. The rest are more just validation steps. So I suggest you include those just to make sure that it's working. Once you're confident, you can either delete them and respin it up, or we can just remove the containers at a later date. And I suggest you go and do that because then you'll at least learn how to get rid of containers because you're going to need to know how to do that anyway in the future. So at the end of the script, I simply download an Nginx deployment and I specify that I want this to be exposed. And you can see that at the bottom of step 8. So expose the deployment. And the key bit here, the magic, the real secret sauce, is the type load balancer. Now that instructs, and Kube is listening for these requests, it instructs Kubernetes to say, hey, this needs to be exposed. And what it does is it picks the first available address within that space. So in my instance, it was 3.60. And then you can access that. And you can see that in the video that I posted earlier. And we'll get onto it in a minute after we've deployed it. It then spits out all of the details for your node. And I've actually put in a little timer here, which isn't that graceful. And there's a to-do on that. I need to basically query the cluster, wait for a command that says it's ready, and then I can get rid of this bit. But it's just in there to make sure it works for now, because I wanted to get this out the door so you guys could get it up and running, and it's really not that important. Even if it wasn't ready, these commands would just fail, but give it a little bit of time and you could rerun them and they would work. They'd just be in a pending state. So now we've done the config review, let's get into deploying this thing. And like I said, there's just 2 things you have to do really. So back in my Proxmox, you can see that I've got the 5 virtual machines that we created in the last video using that cloud deploy, that cloud initialization, which is awesome. If you haven't done that, I recommend you go and do it. It'll make your life a lot easier. But as I mentioned in my description and walkthrough of the script, I actually created another virtual machine for just administrating this. Now, I could have used any, but I chose to spin up a new one using that method I just mentioned before. So I'm actually going to run all of these commands from this virtual machine here. And I've actually logged into this machine here. Now, this is the admin one, and you can see that it's just a blank home directory. So the first thing we're going to need to do is to copy across our certificates. And all you need to do is to just paste those into your home directory. That's it. The script is going to take care of the rest. What it's actually going to do is put it in the .ssh folder and just change the permissions to 600. The last thing you need to do is to copy either curl or copy and paste, whatever you want to do, the script onto your home directory. So I'm just going to do it the real simple way. I should be doing this through the command line interface, but what the hell. And I'm going to create K3S .sh, then I'm going to copy and paste the script from GitHub into here. And that's as simple as this. Once that's done, we just want to save it. So that's saved. And then the final thing you need to do, because if you refresh this, it's not executable. So just right click that, change the properties, hit an X in there, or do a chmod so that you can execute this. And that's it. So let's launch the terminal. We're defaultly in the home location. So fingers crossed, this should be as simple as doing a / and then a K3, hit tab, and let's hit return. Looking good so far. So K3S wasn't found, so it's going to go and pull that. Kube control was not found, so it's going to go and pull that. And I'm going to preempt this. Docker won't be found because, again, this is a bare image. So it's going to go away, use the convenient script for Docker, and then install that so it can run the rest of the script. Now, unfortunately, my internet connection is not very fast, so this process takes a while, so I'm going to skip through this bit now and see you on the other side. You can now see that it's installed Docker. It's now going through and accepting all of those keys for all the virtual machines. It's now installing K3S install on that first master node, so remember, this is our lead. What it does is it downloads the K3S binary, spins it up with all the parameters we've got. On this first one, it's going to copy across the kube config, which it's just about to do in a minute once it's started up. As you can see, it's starting K3S. There we go. We've got the first green message that the first node has been bootstrapped. It's now downloaded that Docker image, and at the top, you can just see it's generated that daemon set. Now it logged in, and you can see that in the middle here. It logged into the first node and it copied that file across. And now it's onto the next section, which is the K3S up join. It's now joining the second master node. So that's master nodes 2 and 3. And it's doing exactly the same thing, going away, downloading the binary, and then continuing. I could probably make this a bit smarter in the future, download the binary once, and then copy it over to those machines. Probably not an issue for you, but I'm on copper broadband, so it's terrible. Now the second master node's installed, and it's going to go and do the third. Now the third is installed, and it's going to start installing our worker nodes. Those are those agents. And you can see that just by checking the IP address here. It says that for each of these that it's going to do. And now we're on to the final agent, and fingers crossed, if this all works, we should have a cluster up and running in just a few seconds. And it's just about to finish the last one. Yep, it's done that. Then it's gone away and it's created that VIP cloud control. So that's downloaded those RBAC files and all the configuration files for kube-vip. It's then applied that to the cluster, and it's also pulled down and deployed Nginx. And now it's doing that little 20-second wait, which I want to get rid of in the future. But in 1 second, there we go. It's printed out everything. So let's quickly validate our cluster. Here we go. We've got at the top, we've got all of our nodes. So we've got 3 masters, and you can see that with the master label. And it's also got the control plane and etcd. That looks good. The 2 below it have none for their roles. That's because they're not containing any of these, and they are going to be specifically for our workers. That looks good. Moving on, I've queried what services are running on here. Now, it's got 2 services. It's got the internal cluster IP, and importantly, it's got the Nginx 1 type load balancer, cluster IP, and then external IP. That's what we want. And you can see it's mapped to port 80. So this is a bit similar to how Docker is and how you would expose things on there. So in a minute, I'm going to show you if I go to this IP here and that port, I should reach Nginx. And then the last bit is just showing you all of the pods that are running within our Kubernetes environment. And as you can imagine, this is a fresh install. There's not a lot going in there, but you can see that Nginx has been deployed on node 4. Actually, you can't. Let me just resolve that. There you go, node 4. So now's the moment of truth. Let me hit that IP address and let's see if we've got Nginx up and running. So I'm going to open up a new incognito tab, just so you know there's no trickery here. And if I go to the IP address, let's see what happens. Yes, we did it. Single click, K3S, there we go. And all done with load balancing and HA through kube-vip. There's not a sign of metal LB here, and we haven't had to worry about things like Ansible. Now let me reiterate, that's not a dig at either of those, and you could probably argue that I should have done this through those tools. But I wanted to make this as simple as possible, and we can build on the foundations from here. So I hope you found that simple to follow, and sorry that I went through every control, but I think it's really important that you understand what the script's doing and a little bit more about how K3S works. Don't worry, there's a ton more to come. So please have a look at this script. I hope you can get it up and running. If you don't, come in my Discord, drop a note in the comments below, and hopefully we can get you up and running. Like I said, I've given you exactly my setup and which machines I was running on, which versions of Ubuntu. So if you replicate that, you should be okay. And I have faith that you can use others and it should work. I just need more of you guys to go out there and test this thing, and then we'll improve it and we'll make it better. In the next video, we're going to be focusing on Rancher. So we're going to be putting a GUI in front of this so that we can access it through our web terminal and get away from just having to use the command line interface. Now, we do want to stay sharp on those skills, so we will be needing to use some in the future, but a lot of this now can be driven through Rancher. So next video, we're going to deploy Rancher and we're going to get this cluster managed through the web interface. It's a bit like Portainer, but it's made by the same people that make K3S. So I hope you've liked this video. It's taken me a hell of a long time to create this script and test it and get it all up and running. If you did like it, please give it a thumbs up, please subscribe and drop a comment below. And also, if you want to support me through the membership, I'd really appreciate that. So good luck in spinning this up. Take care everybody, and I'll see you on the next one.